So one other thing that came up in going to the breakout rooms on Friday that I want to talk about is there was a problem where in the problem where you were printing the timestamps on for the runners. I think that was exercise 3. Exercise 3.2 or something like that. Yeah, 3.2. There's a problem there in that if we scroll up, I probably don't. Did I say anything here? No, I don't really say anything here. If you look at the problem statement, you're supposed to say things like runner 42, 10, 1, 12, 09, and that's supposed to generate runner number 42 passed mile 10 at time 1:12:09. So you're supposed to do stuff like that. And there were people that ran into problems because they were trying to do things like, there are 3 in here that I don't want. They were trying to do things like, oh, here I'm just gonna, and this would have been an argument in the real problem, but I'm just trying to illustrate the issue people were running into. So people had things like this, and that didn't work for exactly the reason we talked about below. If I try to do this, I'm going to get an error here because this is a string and that's a number, and Python's like, I don't know how to add strings and numbers. Okay? And so the solution I intended was that you would just convert, you would convert the number to a string using str when necessary. That's what I was expecting people to do. And that will do the right thing, okay? And so in the runner thing, you're gonna need to convert this. Inside the body of runner, you're gonna have to have a stir to turn it into a string in the appropriate place. And this is also a number, and it will have to be converted to a string in the appropriate place, okay? And that was what I expected people to do. Now, some people did some looking on the internet, which is totally legit. Definitely, actually, you know, one of the things computer scientists do is they look things up on the internet all the damn time. If you ever watch sort of somebody experienced program, they seem to be Googling as often as they're actually typing code. And so that's a totally legit thing to do, but it can there's a couple of things to be careful about. One is it can get you ahead of the game. So in this case, the students found something that we hadn't talked about and that we weren't going to talk about anytime soon. So then that confused the other people in their group who were like, what is this thing and where did it come from? So you got to be careful about that. The other thing to be cautious about is there are 2 distinct versions of Python in the world called, weirdly enough, Python 2 and Python 3. Python 2 was meant to be made to go away. The idea was that Python 3 would replace Python 2. But an awful lot of people had written an awful lot of code in Python 2. And so they were really kind of grumpy about having to rewrite all that to make it work in Python 3. And so frankly, just a lot of people didn't. And so while Python 2 was initially scheduled to have disappeared a decade ago, it's still in use. And in fact, Jess uses Python 2, not Python 3. So most of the Python you'll find if you Google Python stuff will actually be Python 3 these days. Most of that will work in Jest because most of Python 3 is the same as Python 2, but not all of it. So be prepared to find, if you're going to use the internet as a resource, be prepared for the possibility that you're going to find Python 3 stuff that won't work in Jest in Python 2. You might find things that are Python 3 that work fine in Python 2 and work fine in Jest, but it's hard to know until you try it, okay? So you've got to be a little careful about that if you're going to use the internet as a resource here. Apologies, I wish that weren't true, but it is, okay? One of the significant differences that actually won't hurt you any is in Python 2, we can do things like print space 5. In Python 3, print became a function, and you have to have parentheses around it. Turns out it's okay to have parentheses around it in Python 2. So if you see people using parentheses with print, that'll still work here, and that won't cause you any problems. So that's an example of a change that won't actually hurt you here, but there could be other things that will fail to work in Jest, and so be prepared for that possibility, okay? Questions about that before we talk about the particular format tool that people found? Because I do want to say a little bit about it. Okay, so there is a format instruction that applies to strings. And so if you have a string, I am years old. Oh, so let's make this a little fancier. Let's say my name is and I am years old. So there's a string, okay? The open close curly braces with nothing in them, those are used in this format command as markers for where values are going to go. And so you can say dot format, and then because there are two blanks here and here, we have to provide two values to format. And so format takes this string, puts this first value in the first blank, second value in the second blank, third value in the third blank, fourth value, you know, if there are more blanks and more values, it lines the blanks and the values up. And so if we run that, I probably should have done that down in the command window, but whatever. That didn't work. Shouldn't. No, I mean we could, but I don't think it hurts. It should just, if you just have an expression, it should just run the value. Essentially a do printing. So that's not the problem. It says that string has no attribute format. Am I spelling format wrong? Or something? I'm not spelling format wrong. Python string format. Maybe is that a Python 3 thing? So actually, Dongcheng, I remember that your group was using format. Did you ever get it to work?
Yeah, I got it work. So do you need to copy the code from the chat box?
Format. Huh. No, that looks like mine. Like what am I doing wrong? But thank you for sharing your code. But I've got, maybe I need to, do I need to put oh, come on. What am I doing? Do I need to put parentheses here for some reason? I don't think so. The program, nope, that was not the issue. I didn't think it was. Gonna undo that. And that looks like the chat code that Dongting shared. Oh, no, that's not it. Dot format and then stop. Well, I hate computers. I think I'm joking. What if I, just for fun, I'm going to drop this down here. str object has no attribute format. What in the world? Oh, I'm sorry. I totally know what the problem is. This was added in Jest 6.0, and they've got Jest 5 on this computer. Because that was a problem I ran into on Friday. Was that you? Ah, so it works. No, I've asked them to upgrade it to 6, and because they're so desperately busy doing 1,000 other things, and I said, oh, it's not a huge deal because I didn't expect this to happen where I look stupid in front of a large group of people. Hi, everybody. I didn't push them to do it, but that's why. So this should work for you. It just won't work for me because I'm running an old version of Jest. Yeah, so I have Jest 5 point something on this computer. And so it does work on Jest 6. So for most of you, it will work. And so format will put the first argument in the first hole and the second argument in the second hole, etc. And this is the part that's convenient for the exercise, things that need to be converted to strings are automatically converted to strings for you. So the fact that 57 is a number here, but it needs to be put in this string, it will be converted to a string before it is inserted. So I was expecting you to use pluses like this and explicitly convert things to strings, but you can use format. Format will work. It's an okay thing, assuming you've got Python 6. And I have Python 6 at home, and the TAs will have Python 6, so that should be fine. I think it's just, I don't have permissions to update Jest on this computer myself because this computer is controlled by IT. And so I can't do anything about it here. But on our own equipment, we should be fine. So if you want to use format, I think that should be a fine thing. Don't feel like you need to, but, and I would encourage you actually to make sure you can do it both ways, because both approaches are probably useful to know. Okay. Whew, that was confusing and slightly embarrassing. So thank you everybody for your help and patience. Questions? What time is it? 9:48. Okay, we used about half an hour. Any other questions about the lab stuff, things, go, boom? Okay, so I'm gonna make a new program for today, for the rest of the day. And I'm gonna talk about some stuff. In particular, I want to talk about for loops some because we will use for loops a lot in this class. Jess uses for loops a ton as a way of dealing with the components of pictures and sound files. So if we have a string, that string has a certain number of characters. We can, in fact, ask how many. We're going to save this. So Monday, 2020-08, 31.py. It has 10 characters. 1, 2, 3, space, 4, 5, 6, 7, 8, 9, 10. Okay. So len is built in to Python. That's a Python thing. And you can hand it a string and it will tell you how long that string is, how many characters it has. And notice that spaces count as characters. Also, punctuation counts as characters. So if I say len my name, oops, bring out this, my name, McPhee, has 10 characters. So it's counting the spaces, it's counting these open and closed parentheses, it's counting these single quotes, it's counting the digits, it's counting this period at the end. All of those are actual characters in the string and are counted in computing the length, okay? Now, there are times when it is useful to be able to say, I want to go through a string like this and I want to do something specific to every character in the string, okay? And you do this all the time in your life, right? There's a set of students. I want, a set of turned in assignments. I want to grade each one. I don't want to do it all at once, right? I want to be able to say, okay, this is Joseph's assignment. I'm now going to focus on it and grade it. Done with it, set it aside. Now I'm going to go do Thomas's assignment, finish it, set it aside. I'm going to do Juan's assignment, set it aside, right? When you do dishes by hand, you don't clean all the dishes like together as a big blob, right? You wash this plate and you set it aside. You wash this cup, you set it aside. So you're iterating through the things that you need to work on and doing each one at a time. And a for loop does exactly that. A for loop allows us to go through the letters in a string, and later on, it'll turn out we can go through values in an array, pixels in an image, samples in a sound. So we can loop through a lot of things, anything that can be broken up into a sequence of components. We can go through that and process each one of those one at a time. So I could do something like def, print, characters, and I could say for CNS, print C. So what is this doing? This for CNS thing. This is a really important Python construct. Notice for is bold and sort of a dark blue like def is, and same for in, okay? That's telling you that for and in are keywords in Python. They're built into the language, and we can't change their meaning. They will be what they will be. And so this says, for every character in this string, do something. For every dirty dish in the sink, do something, namely clean it and put it away, okay? For every assignment that's been turned in, do something, grade it, and submit a grade, okay? So take some action for everything in a collection of things. Questions about this? This is actually a super important concept. So if you've got questions, definitely holler. Okay, so notice also that this has a colon at the end of it, in the same way that def had a colon at the end of it. So a colon here is essentially saying what follows is a block of code that is attached in some way to this line. Here, the block of code is these two lines, and they are attached to this in the sense that they form the definition of print characters. Here, the indented code is print C. It is attached to this for loop in the sense that it is what is called the body of the for loop. It is the thing we are going to repeat over and over again for every character in the string, okay? And so we have to have a colon at the end of the for loop, and the body, the stuff we want to do, needs to be indented relative to the for loop. It needs to be in relative to the for loop. That's how we tell Python that this print line is part of the body of this for loop. And if we wanted to have something after the for that isn't part of the for, we would have to outdent it so it lines up with the for. So you could say print, we are done, okay? And this will not happen for every character. This will happen once after all the characters have been processed. Okay? There's a lot there. I mean, there are not a lot of characters, but there's a lot there. So definitely ask questions. Comment that out for a second. Load. So now name should be Nick McPhee. And if we say print characters, name, we got, make it a little bigger so we can see the whole thing. NIC space MCPHEE, we are done. So it printed each character one at a time, and then it printed we are done when we were finished. Okay. Questions? Definitely feel free to ask. There's a lot going on here, and you're going to have to write a lot of for loops before you're done. You will write many, many for loops this semester. Now, we can do complicated things, like here we just printed the character, but we could print like the ASCII code for C, is ord C, okay? And so for every character, instead of just printing the character, we're going to print a whole sentence that says the ASCII code for some character is, and then we'll have its ASCII code, and then a period. All right? Now there's a small mistake in this. Does anybody see it? It's going to prevent it from running. What kind of thing does ord return? What kind of value does ord give us? Do you remember? A number. And can we do a plus between strings and numbers? We cannot. So we are going to have to actually say str ord. Get that to not shout at us. So weirdly enough, we're going to take the character, turn it into a number, which is its ASCII code, and then turn that ASCII code number into its character representation. Kind of strange, but we need to do it if we want to print this way. And so now, if we say print characters name, the ASCII code for N is capital N is 78, little I is 105, little c is 99, space is 32, M is 77, yada, 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 yada. Okay? And that would be a nice way to automate the last question on the quiz for chapter 1, for example. If you wanted to go back and have a look at that. You could use a program like this to generate the ords, the ASCII codes of all the letters in that string. Yes, sir?
Would it still function if you replace all the C is variable with a different variable?
Indeed. So I could, C is just a name. So I could say for small bump in S, and as long as I change all the occurrences of C with the new name, this will work fine. So C is just a name. The fact that it's in sort of small, non-bold black helps tell you that it's something you get to choose. And as long as you use the name consistently, then you're good. So you could use whatever name made you happy. Okay. You know, char might be a better choice. Help indicate that it's a character, or even writing the word character out, right? If you wanted to. Any of those would be fine. And notice that S is also a name that I chose and could totally change to be something else. And that will still do the happy thing. Good question. Other questions about this example? And I will not go through all the examples in the book. I mean, there's just not time. You know, it would take us forever. So I am expecting that you read the chapters and that you ask questions about things that you're unclear on. So I will try to highlight pieces that I think are important or just interesting to me, but don't feel like, you know, I'm going to cover it all. And if there's a thing in the chapter that you're like, I did not understand that, that made no sense to me, you should definitely ask, okay? So let's do one other thing here, and then we might run out of time, we'll see. So for is an important piece. Another thing that we haven't talked about yet, so it turns out that if you want to be like really math nerdish about this, and we don't need to be in this class, it's not important, but there are a handful of features that a programming language has to have in order to be what we call in the field Turing complete, which you don't really care about what that means, but most programming languages are Turing complete, and it means that any program you write in one language can be written in all the other Turing complete languages as well. It might be easier or harder in some languages, but they all have effectively the same power. Anything you can do with one, you can do with another. So it is a choice, not a necessity to use Python versus Java versus whatever, okay? Two things that you have to have for Turing completeness. Well, there's three things that I'll mention you have to have for Turing completeness, two of which we've seen. One is the definition of functions. You have to be able to define functions for Turing completeness. We can do that. You have to have something like a for loop. We just learned how to do that. So we're, got two of these things done. A third one that we need is what are called conditionals. You have to be able to say, if this is true, do one thing. If it's not, do something else. That's a vital thing for a Turing complete programming language. And if you think about it, it's really important in your life to be able to ask if-then questions, like if we're just about out of milk, gotta go buy more milk. If this class is full, ask the student if they want to be added to the waiting list. Otherwise, just like reject the registration altogether. So that kind of stuff. If they don't have enough money in their bank account, then don't let them withdraw that amount because they can't cover it. So these kinds of, if this is true, then do something, otherwise do something else, very critical in computer science. And so we're going to combine now a for loop and an if, which is the Python conditional tool. And we're going to do a variation of print characters that's going to be called justVowels. And here, instead of printing all the characters, we only want to print the vowels. Okay? So basically we want to say if char is a vowel, okay, and this isn't Python, we'll talk about how to do that in a second. So if char is a vowel, then we're going to print it out. Otherwise, we're not going to print anything. Okay? So that's the basic structure of our little program. We're going to loop through all the characters in the string again for char in string. And then if character is a vowel, and we don't know how to do that part yet, then we'll print the character. Otherwise, we won't do anything. We'll ignore that character and just go on to the next one in the room. Okay? Does this, you look like you have a question.
It's not going to understand what a vowel is right now, right?
No.
Okay.
So we're going to have to do something about that. It turns out that we can do something that reads a lot like the English here, though. We can say in, and then we can provide a collection of letters that are the vowels. So char in this string will be true if char is an A, an E, an I, an O, or a U. If it's any one of those, this will be true, and we will print the character. If it's a T or a W or an X, it will not be true, and we will not print the character. So we get sort of a, so we're essentially defining the set of vowels here. And if we wanted to make this more readable, we could actually say vowels equals A, E, I, O, U, and then we could replace the string down here. Oops. Oh, stop it. Vowels. Right. So we can make it a little more explicit that we're defining the set of vowels here, and then saying for every character in the string, if that character is in our set of vowels, we will print that character. Okay? Questions? So if we load the program and we say justVowels. So in my name, I-E-E are the only vowels. So I here in Nick, and then the two E's at the end of McPhee. University of Minnesota Morris. We don't get the capital U. We'll talk about that in a second. I-E, I-O, I-E-O-A, O-I. So we get the vowels. Now, why did we not get the capital U in university? Yeah, it's not defined here in our string. Case matters. We have little u here, but we don't have big U here. So if we wanted to fix that, one easy solution would be to put the uppercase versions of the vowels in there as well. Now, if we say justVowels, and I'll just do university so we don't have quite so many letters, we get the capital U, the I, the E, and the I. And notice we don't get Y because we didn't put Y in there, and depending on who you ask and when, Y may or may not be a vowel, right? This gets, the simple question of only printing the vowels can get complicated fast. So I'm not going to dwell on that bit of linguistic history, and we'll just stick with these guys. But yeah, you can imagine it gets more complicated later on if necessary. Yes, sir.
Let's say I want to find every time that letters U and N were next to each other.
Okay.
How would I present that? Because right now I see that all the vowels are in a string and are defined. But how would I search for only when two letters are next to each other, like that specific?
Gotcha. So that's actually a slightly tricky question. That I don't want to answer today, but I do want to answer. So actually, I might ask you to hold that until Wednesday, because I'm a little worried it might take longer than we have today, and I don't want to get halfway through it and then have everybody forget what the hell we're talking about. So if you can help me remember to start with that on Wednesday, that would be awesome, because I think that's a great question. So I just don't want to get buried in it with 10 minutes left. The for loop, as we're looking at it right now, would only let you do single letters. But there is clearly a way to do what you want to do. We just have to, yeah, we'd have to figure some things out. Okay? And then we can also have a function that does non-vowels pretty easily. For char in string, if not char in vowels, print char. So not is a built-in thing in Python that lets you negate or invert the meaning of a test. So we should be able to say non-vowels, McPhee, and we just get MCPH. And non-vowels, Morris, we get Moose. Okay. Which are like this in some sense is more readable. Like it would be easier to try to guess what the original word had been than if all you have is the vowels. Like if all you have is UIEI, guessing that the word was university would be a challenge, right? Whereas if I say non-vowels, university, you might guess that that was university. I mean, I'm not saying it's trivial, but I think it's a lot easier than if all you had is the vowels, which is why a lot of names on the internet are things with a vowel removed. Like it's very, considered very clever to remove the E and ER at the end of things, like Flickr and stuff like that. Because they're still kind of recognizably the same word if you remove a vowel here and there. But it makes them more Googleable. Like, Flickr spelled with the ER is an English word, and you Google it and you're going to get a bazillion things that have nothing to do with the photo sharing site Flickr. You remove the E, now it's something that's recognizable and memorable, but also Googleable, which is highly valuable from a business perspective. Okay. So we've done a lot there. Like we've really done a lot there. Right? For loops, if, in, and not. 4 major things have happened in half an hour. You should be kind of like, oh my God. Or be, man, we are learning so much per half hour. This is the most amazing class ever. Or you could just go back to, oh my God. I'm cool either way. But we've covered a lot here. So if there are questions about any of this, absolutely ask. Questions? Anything in chat, online? Okay, so there's one other thing I'll mention here quick, and then I think that'll wrap us up. So far, thanks for the thumbs up. Appreciate it, folks. So far, everything we've done is we've been printing things. There are times, like if you think about it, it would be more useful instead of printing the string with all of the vowels or only the vowels or not or all the non-vowels. It'd be nice to make a new string, because if you print, like it's there, but you can't really do anything with it. It's a bit like putting it on a billboard. Everybody can see it, but you don't have any way of acting on it. Whereas if you made a new string, then you could print that string if you needed to, but you could also pass that string around as an argument, save it with a name, store it in a file, bring it up later. There's a lot of things you could do with it if it was a string that you can't do with it if all you're doing is printing. So it'd be nice if we could do better than that. So let's actually look at how we might do that. So if we were to say def justVowels to string, and let's just start by just copying what we've got, and then think about what we would have to do to make that not print. Well, the problem is right here, right? This is the line that prints. So we're going to have to do something different than print there. Okay? And if we want to make a string, instead of printing, basically what we want to do is add that character to the string that we're building up. Right? We're going to be building a string by adding characters to it as we find vowels. Okay? Well, we know how to add two strings together. Plus does that. So if we had something like result gets result plus char, that would take this character and add it to the end of that string result, and take that new string or new value and make it the new value for result. So we'd have the old value of result, we'd add the character, and that would become the new value of result. And then at the end, we want to return result. Because result would be the string we would get by tacking on all the vowels in this case. Now there's one gap in this. There's one omission that we have to fix. We haven't said what result is at the beginning. What's result's initial value? How do we start it off? So if we're going to be taking a string and adding the vowels to it, what is that string at the beginning before we've added anything to it? What string do we have there? The empty string. Like initially, there are no vowels. So initially that string is going to be the empty string. Yeah, I'll do that one. So we're saying start off with nothing, an empty box, as it were. For every character in the string, if the character is a vowel, add that character to our collection of things. And at the end, return the collection of things. So we take an empty string, we stick stuff onto it, and at the end, we hand that back. That's the value we give back. Okay? A lot going on there. Questions? Does it work? justVowels to string. University. We got a string back, and it's got the right things in it. So it took each character. We started off with the empty string, and then when we went through, when char was a U was in vowels. So result was the empty string plus that U, so it became just a string with the U in it. And then we ignored the N, and then we added the I. So U plus I became UI. And then we ignored the V, and then we added the E. UI plus E is UIE. Ignore the R, the S, tack the I on, ignore the T and the Y, and this is the string that we return. Okay. A lot going on. Definitely feel free to ask questions. You have 1 minute. Ask an awesome question in 1 minute. Everybody looks sort of shell-shocked. So a lot of this stuff is in the Chapter 3 assignment. So I would start the Chapter 3 assignment if you've not done so. That could generate a lot of questions for Wednesday. And I am happy to spend as much class time as you want answering questions and trying to help out. So definitely get going on that if you've not done so. Otherwise, go have fun. enjoy the nice day. Now that it's a lot cooler. And I will see everybody on Wednesday. Any questions online? Good. Thank you. See you later.